Good evening, class. Today's science lesson, we shall deal with the water cycle. The water cycle. We are going to look the water cycle. And before we continue, we ask ourselves, what is water cycle? Perhaps it's important we talk first, what is this water we want to talk about? And then we can go ahead to know what water cycle is. Water is one of the most important substance on earth. Water is one of the most important substance on earth. Water is present in the atmosphere. Water is also present on the surface of the earth. And water is also present within the earth, that is underground. So underground the earth, we have water. And maybe if we talk of water in relationship to human beings, we are told that 70% of a human body is made up of water. So our bodies are made up of 70% of water. Then scientists have proved that a human being can survive for a number of days, a number of weeks without food. But you cannot survive a number of days without water. So water is very important. Someone can stay for 30 days without water, without food, but you cannot stay that long without water. So what I'm stressing is water is very, very important. Therefore, water on earth. We want to see how is water, the percentage of water on earth, how is it available on earth, water on earth. Then when we come to water cycle, later on, we shall define water cycle as the process of water, the process under which water goes through from the underground, the surface of the earth, on the surface of the earth, to atmosphere, then from atmosphere again back to earth. This movement of water from earth to atmosphere and from atmosphere back to the earth is what we call the water cycle. It moves in a different process completely. That is water cycle. But we shall try to cover what are these processes, is what we shall study in this water cycle. What are these processes that are undertaken, that water goes through in this water cycle? So maybe we shall start first on water on earth. It is true that 70% of water, 70% of the earth is covered by water. So we can see majority of the earth's surface is covered by water. That's 70% of the earth's surface is covered by water. Then that one leaves us with only 30% that maybe we can have land. Therefore, apart from that, we also have 97% of the water that covers the earth being in the oceans and lakes. So we are told now 97.5% of the water that's available is present in the oceans and saltwater lakes. If 97.5% of water that is available that is present on Earth is salty water lakes. Then what about fresh water? What kind of percentage are we remaining as fresh water? Therefore, we are told this makes it unsuitable for drinking salt waters, and salt water first is unsuitable for drinking. And not only that, also salt water cannot be used for a number of things. For instance, irrigation. Salt water cannot support many plants to grow. Therefore, if you want to engage in irrigation, you cannot just go and pick water from oceans, salt water, and you expect your plants, your crops to grow. No, that cannot happen. So we are seeing large percentage of water that is available on Earth does not support plants to grow. Fresh water, yes, fresh water can support plants to grow, but under what percentage do we have that is available that can support plants to grow? Therefore, we are told that part of the water that is fresh again is trapped underground, and still it's difficult for such a fresh trapped underground water to support plants to grow until there is human intervention to bring this underground water to surface so that it can support plants to grow and even for drinking purposes. Therefore, we are seeing, apart from the remaining small percentage of fresh water, it is also trapped as ice. It is present in form of glaciers and also present in form of ice, glaciers, and so forth, which cannot support plants' life. Plant cannot use water in form of ice unless that water melts, becomes liquid in the correct temperature. Then the plant's roots can be able to absorb, to use that water. And that water should not just be above, but should percolate, should penetrate within the soil so that it becomes available to the roots of these particular plants. So we are seeing it is only 0.01% of water on Earth that is renewable, fresh, and available for use. That percentage is minimal, minute, but that is what we call fresh water. Renewable, 0.01% of water is fresh and available. Fresh and available for use. So apart from this 0.1, we know we have water that is fresh, but it is not in a state that can be used. It is frozen, it cannot be used. It is in the form of glacier and ice. So we are seeing that one leaves close to 2.5% of water is underground water. 2.5% of water is fresh but trapped underground. Trapped underground or in form of ice, and it is in form of ice and glaciers. So we can see that water that is available for use, it is 0.01. For us to understand the nature of water in different states, we can have a diagram indicating these different levels of percentages of water that is available on Earth. There's one particular percentage of water that we have not covered. Maybe we shall think of covering it later on. What about the percentage of water that is available in the form of water vapor or in the atmosphere, in form of clouds? What kind of percentage of water that is up there in the skies or in the clouds? That percentage will not be indicated here. The earth is not the atmosphere. The earth, we are dealing with the earth first. So we can have a simple diagram like so. Then this diagram can show, this diagram can assist us understand the availability of water on earth. This one, the larger part of this diagram is indicating the ocean, water in the oceans. And that one is 97.5%. So we can see it covers large part. If this diagram is a representation of the earth, then you can see the earth surface, the large part of the earth surface, it is representing the 97.5%, which is salt water. Then we have this blank space within the diagram that is representing the earth. It's ice and underground water. Ice and underground water. That is ice and underground water, and it is 2.5%. That is 2.5%. Yes, it is fresh water, but it is not available for use. It is either trapped underground. Maybe for us to reach it, we need to penetrate through impervious rocks, or this water is fresh, but it is trapped on the hilltops, on the mountains, peak of mountains, in the form of ice or glaciers. Then we have this small dot. The small dot that I'm indicating is from black. The small dot is renewable fresh water. This is renewable fresh water. That is renewable fresh water on earth. Renewable fresh water on earth and available for use. It is available for use. Its percentage is 0.01%. So the water that is available for use is minute, is tiny, but that is the percentage of water we can use. The only way we can improve the water that's available to use is maybe to penetrate and to see whether we can use the underground water. Now, we have seen the percentage of water on earth. Now we can now look at the water cycle. The water cycle. Now, on water cycle, the water on earth has been recycled over and over. We are saying the water on earth has been recycled over and over. Maybe we can talk of a molecule of water that maybe if it rains as in form of rain, droplets, the way it will move again, it will soak into soil, it will percolate, or maybe through runoffs, it will join maybe the river stream back to oceans, then through evaporation, it goes back to the atmosphere. Then when it goes to atmosphere, there is condensation, it will cool. Then when it cools, it will come back down as raindrops. For this cycle to complete, for this particular water molecule to complete this cycle, at times it can complete in a short period, At times, it can take it a long period to complete, depending on factors that affect water cycle, the movement of water from Earth to atmosphere, from atmosphere back to Earth. We shall come and see that. So we are saying the water on Earth has been recycled over and over since the planet Earth was formed. We are not dealing with how the Earth was formed, but we are dealing with this water cycle has been recycled a number of years and millions of years. The natural process now, the natural process of recycling water is known as the water cycle. I repeat, the natural process of recycling water is known as the water cycle. You see, the movement of water from the Earth to atmosphere and from the atmosphere back to the Earth is a natural process. It is not man-made process. It is not aided by human beings. It is natural that water will move from Earth to atmosphere, then from atmosphere back to Earth. It is a natural process. So we are saying this natural process of recycling water is known as the water cycle. That is what we are studying today. As water moves through the cycle, it changes state. We are saying as water moves through the water cycle, it changes state. Liquid water is available and is present in oceans. Liquid water is available and present in oceans. And it can change into water vapor through heat from the sun. If the sun, through sun's rays, this water can be heat by sun's rays, and if it's hit by the sun rays, this water will change, it will evaporate. And if the water that is a heat, if the light from the sun hits these oceans, the lakes, the different rivers that are there, even the trees that will lose water through evaporation, this water will go back to atmosphere in a different state. The water in the ocean will change from its liquid state. When it evaporates, it becomes water vapor. It is different now. It is no longer liquid. It is a vapor. As water vapor rises up in the atmosphere, it cools. At a certain height, it cannot hold, the air cannot hold any longer. The water vapor, hold any more water vapor, the air is said to be saturated. We are saying when water vapor rises in the atmosphere, it reaches a place where it's cold. It is normally the higher you go, the cooler it becomes. So it reaches a particular height where it is very cold. The air is very cold. Therefore, this water vapor condenses. When it condenses, that period when the air can no longer hold any water vapor, then we say the air is saturated. Saturated air. Saturated air cannot hold more water vapor. It has reached limit. And when the air reaches the limit to hold the water vapor, this water vapor now will condense and start forming rain, small drops of rain. These small drops, they can even form clouds and so forth. So we are saying any further cooling causes water vapor to condense, changing into tiny drops of liquid water. Any further condensation of water vapor will change into water vapor into tiny droplets of liquid water. Now, these tiny droplets of liquid water, if they amalgamate, then they form clouds. Now, we are told 86% of evaporation of water is from oceans. 86% of evaporation of water is from the oceans. Why do we say so? Why do we say 86% of water is from the oceans? We say so because first, these oceans are bigger, are larger water bodies. Because oceans are big, they have large surface area. Therefore, we expect from the large surface area, they will be able to be met with a lot of sunlight. And if there is enough sunlight, then evaporation will take place on these larger water bodies than any other small, tiny vessels of water. So we are saying 86% of evaporation of water is from the oceans. Then we are saying cool air holds less water vapor than warm air. I repeat, cool air holds less water vapor than warm air. In cold air, water condenses to form clouds. In cold air, water condenses to form clouds. Then these clouds can come down in different forms. They can come down in form of precipitation in different forms. Precipitation can take different forms, either liquid rain, dropping as rain, or dropping as hailstones. At times hailstones will fall, or to come down as snow. Now we are saying when air cools further, the droplets of water combine to form longer, larger, heavier droplets which fall back on Earth as precipitation. Precipitation. So we are saying the process of water coming down from atmosphere back to Earth, it is what we are terming as precipitation. And we are saying precipitation can take different forms. We can have precipitation in terms of rain, droplets of water, and we call it rain, or ice, or we can have those small hailstones. It is still precipitation, or snow. The water can come back from atmosphere to Earth in the form of a snow. You wake up, you find the whole environment snow. That's precipitation. The precipitation, water can come down in different forms. So we are saying precipitation may be in the form of a liquid rain, or may be in the form of frozen falling, may be in the form of frozen hailstone, falling to the earth in the form of snow or hailstones. So it's either rainwater or a snow or hailstones can come down. Whatever those three forms, it is still precipitation. Water is coming back to earth. Then we are saying it may flow. The water may flow on the surface of the earth as runoff. Whenever it rains, when precipitation has taken place, whether it has taken place in the form of the snow, or it has taken place in the form of hailstones, or rain itself, hailstones will continue to melt, and when it melts, it will create water will start moving down. When runoffs are formed, when they are formed, they will continue moving down depending on the topography, how the landscape is. If the landscape is steep, then we expect more runoff, and then less percolation. If the land is very steep, water will not percolate, will not soak in soil. Instead, it will be running more than soaking in. And depending also on the nature of the soil. Different types of soil have got different level of soaking, of taking in water. Even different rocks also have different way of absorbing water. So we are saying it may form the surface, it may run on the surface as a form, in form of a runoff, moving back to rivers, lakes, streams, and eventually it will flow back to the ocean. So when it rains on the surface, it will now move on the surface depending on the topography. This water can move to form rivers. If it forms rivers, it will continue running maybe into lakes or back to oceans. It may soak down into the soil. The rainwater, it can soak down into the soil in a process called percolation. So the water that will not run to form rivers, the water that will not go back to the ocean, then it can experience this situation called percolation. Percolation is the way water sinks within the soil, or the way the water soaks in the soil. We call it percolation. And one thing with percolation is, through percolation now, it is where now this water comes into contact with the roots of plants. And when it comes into contact with roots of different plants, then the plants can be able to absorb this water. And when it absorbs this water, now this water will be transported in different parts of the plant, through the stem, through the leaves, and so forth. And through the transportation, we normally talk of translocation, where when water is being transported, it can move along with the different elements and nutrients that the roots have absorbed from the soil, so that water can move now. Translocation and the transpiration can take place, where the water now will leave the stems because of the heat of the sun, and will leave the leaves because of the heat of the sun back to the atmosphere. We can have a slide diagram here explaining this process of precipitation. How we find there is precipitation, there is runoff, then there is percolation, then rivers are there. We can have that diagram here, just to give us an insight on what exactly happens. So we are saying precipitation takes different formats. So we can have our precipitation. When we talk of precipitation, we are saying water, the water that is in the atmosphere has cooled down. The water vapor has cooled down. It has formed small, tiny water droplets, forming clouds. And now it's coming back to Earth in three forms. It can come back in form of liquid rain, it can come back in form of a snow, and it can come back in form of hailstones. Whichever way water will come, it's still okay. We can have our Earth here. Then this one, we can say it is a river. So precipitation, water is falling down. Then when it falls down, we can have these arrows. Those two arrows are showing runoff. When the water falls down, depending on the topography of the land, where is high and where is low, the water will always move from high to low area, unless there is a change of gravity interference, but water will move from a higher level to a lower level. So there will be runoff. When this runoff is there, then runoff will formulate rivers. Then rivers will continue moving to lakes and oceans. So what we are seeing here, these arrows with the dots is what we are calling percolation. Percolation is the ability of the rainwater now to sink. It depends also on a number of factors, but this water that is percolating, that is being soaked by the soil, it is the one that can be used now by plants' roots. the plants that have the roots can be able now to absorb this water that is percolating within the soil. It can be able to take that water and use it. Then we have this water that's run off to go back to the river and then go back to the ocean. And we know that the ocean had lost that water to atmosphere through evaporation. We are seeing what we call a water cycle. Then this is what we call our soil. Our soil. So this diagram slightly shows what happens on water. There is condensation. After condensation, we have precipitation. Then precipitation, different forms. It takes different forms, whether it's snow, whether it's ice, or whether it's rain or liquid rain. And then it's found itself on the surface of the earth. Then there's a runoff. Other water, we have other water percolating, another one will run and formulate rivers. Then the rivers will go back again to oceans. So we are saying this. Some of the water that percolates through the soil, is taken up by the roots of the plants. And this moves through the plant, and then through the system of heat from the sun, you can find that this particular plant can lose water in their stems, just the stems as they are. If there's a heat from the sun, then water can be lost to the stem to atmosphere through evaporation. And if there's water transported to the leaves, still those leaves can lose water again to the atmosphere through evaporation. And even flower, different parts of the plant will lose water to the atmosphere depending on the intensity of the sun that is there. The process of evaporation of water from plant is called transpiration. I repeat, the process of evaporation of water from the plant is called transpiration. Plants will be able to absorb water using roots. And these roots will be transported through the stem and so forth up to the leaves. But these stems and leaves and flowers can lose water back to the atmosphere in a process called transpiration. So we are saying evaporation of water. The process of evaporation of water from the plant to the atmosphere is called transpiration. Evaporation of water from the plant to the atmosphere is called transpiration. We are saying transpiration is the process whereby the plant loses water back to the atmosphere through evaporation. That process is what we call transpiration. Now, through transpiration, water is returned back to the atmosphere. We have animals. Animals do drink water. Animals do drink fresh water from rivers and lakes. This water is returned also back to the atmosphere as it evaporates from their bodies. These particular animals can lose water back to the atmosphere through even respiration. They can sweat, they are losing water back to the atmosphere. And also, they can lose water back to the ground through a process called, if they excrete. Through excretion, we can say the animals can lose water back to the ground, then to the atmosphere through the sun. They can excrete, lose water through urine. The animal is losing water back to atmosphere, to the land, then back to the atmosphere. Putting these processes together, it creates a water cycle. Putting these processes where the plants lose water back to atmosphere, animals lose water through sweating, perspiration, and through excretion, they are losing water. this process is what we can call an adapt water cycle. Now, let us talk slightly on groundwater. Now, on groundwater, what is groundwater? Groundwater is water that exists underground, water that exists under the surface of the earth. That water is groundwater. So groundwater is water that exists underground. Most of the groundwater is trapped in pervious rock. Most of the groundwater is trapped in pervious rock. What is pervious rock? Pervious rock is a rock that is able to soak water. It can absorb water because it has got some air spaces. So we are saying pervious rock has got water, has got air spaces, and these air spaces can be filled with water. That's a pervious rock. And when it's filled with water, this rock can contain water, because these air spaces, when it's filled with water, then we can say it can contain water. But we also have impervious rock. We have to mention that. Impervious rock is a rock which cannot allow water to soak through. An impervious rock is a rock that cannot allow water to soak through. So you can find that when we are talking about underground water, there is a pervious rock that allows water to soak through. And you find that there are interchange of layers of rock, impervious rock and pervious rock, so that you find that when water goes through, it can be stored for a long period. So we are saying pervious rocks contain tiny spaces into which water can soak. We can have an example to explain what a pervious rock is. We can have an example of a rock, of a glass. If you pick a glass of water, for instance, if we pick a glass of water, then we say these are pebbles, or we say these are sandstones. So if are these pebbles, you can find within this sand, there are air spaces within them. So when you decide to pour water within sand, you will find that water will take spaces, the spaces that are in between the sand. Water will take that space. Now, that is an example of a pervious rock. A pervious rock has spaces within it, and that spaces that is within the pervious rock is now taken up with water. That's how this rock is able to contain and to take water. It soaks water. But when you go to an impervious rock, it has got no air spaces for the water to percolate, to soak, or to be absorbed. Now, what happens on this groundwater? We are saying the water that is available fresh for use is 0.01%. That water is not enough for use. And we know that fresh water that is available in the form of trapped glaciers and ice and underground water is 2.5%. We are interested to use, when we are interested to use this water, then something should be done. So when underground water, when we require to use underground water, then the following methods can be used to extract water that is underground. One, we can make bores. We can dig bore holes When you dig boreholes, we can be able to extract this water that is underground. Or we can have wells. When you construct wells, we can be able to penetrate and reach this pervious rock. We penetrate the impervious and reach the pervious rock where the water is stored. Then this water now can be extracted and be used. Because it's fresh water now, it can be used in different cities. There are cities who have dug boreholes, they have wells, and they're using water that is available in these pervious rocks. You dig, you do whatever you construct, you get them, then you can use them. So we are saying water, underground water can be extracted by constructing boreholes and wells. An example of, and where this water is stored, whenever you find this water stored, where water is stored is from where water is available in plenty under that pervious rock. Pervious rock, and it contains enough water. That place where there's enough water, we call it an aquifer. An aquifer is ground water that is available that you can penetrate and reach the pervious rock. When you reach the pervious rock, you reach the aquifer, and when you reach that aquifer, the aquifer is underground storage water. As long as you penetrate the pervious rock, you reach the aquifer, then you can extract enough water that you want. Let me talk about the Great Attrition Basin, what it is all about. The Great Attrition Basin there are places within the earth, underground, where some levels where you will find the water. Underground water is trapped in plenty and in layers. So the Great Attrition Basin is one of the greatest water basins in the world. Under the sea, there is alternating rocks of pervious and impervious rocks. Impervious rocks do not allow water to penetrate through. They don't have space for water. They cannot soak water, the impervious rocks. So water cannot be soaked into. Some water in these aquifers have been there for so many millions of years. It takes many, many millions of years for water to collect itself, to be found in plenty in these aquifers. Therefore, we want to know the factors affecting water cycle. What are these factors that are affecting water cycle? Water cycle is a movement of water in its different state. Are they factors that affect this movement of water from earth to atmosphere, from atmosphere to earth? We shall see a number of factors affecting water cycle. Factors affecting water cycle. This movement of water, is it influenced by anything? Is it affected by anything? Now, before we go to, when we come to these factors, we can see states of water. That's one of the factors, states of water. And on the states of water, we say water is trapped. Water is trapped in the North Pole and South Pole. And water is also trapped on the top of the mountain in the form of glaciers and ice. That is still water cycle. The water that is in the North Pole, the water that is in South Pole, the water that is on top of the mountains in the form of glacier. It is within the water cycle. but it's trapped. It is difficult, it is hard for water that is trapped in these glaciers, the water that is trapped in the form of ice, to move fast through the water cycle. So we are saying it's a factor where the presence of this water, where is this water present? Is it on the North Pole? Is it on the South Pole? Then its movement within the Earth, on Earth, will depend upon where it is and in what state this particular water is in. Another factor that affects the water cycle is the air temperature. The air temperature. Air temperature affects the rate of evaporation from bodies of water. We are saying the air temperature affects the rate of evaporation from the water bodies of water to atmosphere. It affects the rate of transpiration. And we are saying the rate of evaporation and transpiration will increase depending on the temperature. When the temperature increases, the water vapor will increase. Transpiration will also increase. So the air temperature is important. And we know some plants that grow in the desert, they have a way of fighting this loss of water to atmosphere. Some of the plants will depend on how they have located their stomata. This particular plant, if they want to ensure that they don't lose a lot of water to atmosphere, the stomatas are less and are located towards the lower side of the leaf. Then the nature of the leaves, like for instance the plants in desert regions, is the vegetation of the environment having plants like cacti. If they are cacti, then they are in a way adopted in staying in desert areas. They don't lose a lot of water. Then there are plants, when they know that they're going to lose a lot of water, they shed off their leaves, because having leaves will mean losing water to atmosphere. So that one can affect depending on the temperature. So we are saying when the temperature is high, the water will be lost to atmosphere, depending on the temperature. Low temperatures meaning water will be lost, it will be low. Another factor we need to consider is humidity. Humidity is the amount of water vapor in the air. If the air is very humid, then the sweat remains on your skin and you feel hot and sticky. So the amount of water vapor in the air. If it's a lot, then meaning evaporation will not be high, because already in the atmosphere there is a lot, more amount of water is already, the humidity is high. When the humidity is high, then evaporation and transpiration is low because humidity is high. But when humidity is low, then evaporation will now be high. We can also talk of air movement. Air movement. Moving air is what we call wind. If air is moving, it will affect evaporation, it will affect transpiration. If you are in a place that, if the humidity is high and the wind comes, or moving air comes, then you'll feel some cool, and evaporation now will continue. So moving air affects transpiration, it affects evaporation. So when moving air is there, more water is lost. When there's no moving air, then less water is lost to atmosphere. So it affects water cycle. Moving air carries away saturated water, allowing evaporation and transpiration to continue. So moving air, when it moves, it will carry out saturated. It will carry away saturated water, allowing evaporation to take place and transpiration to take place. So we are seeing that's a factor, air movement. We can also talk of landscape. Landscape is another factor that affects water cycle. When we are talking of landscape, then we have to know what topography is. Topography, when we're talking about topography, we are looking at the nature of the landscape. Are they hills? Are they valleys? Other physical features that are there, are they hills? Topography affects the runoff and the percolation of water. For instance, if the landscape is steep, meaning the runoff the water will run faster. So the ability of water to percolate or to sink through or to absorb by the soil will be less because it is steepy. So what the runoffs, water will run very fast and formulate streams, rivers, and so forth. So we are saying runoff is affected by topography. How is the landscape? How is the nature, the landscape of that land? Steepy, there will be runoffs. From the hills, you get rivers. From valleys, then you will get dams and water that people can drown in because water is not moving anywhere. So you'll find overflowing, water will overflow riverbanks, and even lives can be lost because water is overflowing. So we are saying where we have vegetation, is the surface bare or the vegetation? We are saying the surface that has trees, the surface that has vegetation, grass and so forth, it will be able to reduce the speed of runoff and it will affect the percolation. So where there's vegetation, water will percolate more than a surface that has no vegetation, where water will run without any hindrance. But if we have plants within the runway of water, then these plants will be able to reduce the speed of water that is running, and the water will percolate. So we are saying the kind of vegetation that we have will also affect. Bare rocks, also the nature of rocks will affect the kind of soil. Like when we talk of sandy soil, you cannot compare sandy soil and loamy soil. Sandy soil are very pervious. Water will tend to pass through sandy soil faster than clay soil and so forth. So there's some water, there's some soils that water will percolate through very fast. Other types of soil will resist a bit. So what we are saying, the nature of vegetation on the landscape is very important because that vegetation can stop the runoff of water, and so that water will not run in any speed. Then we can come to another factor. This factor is called vegetation. With the landscape, to how steep the landscape is, hilly or whatever, it affects the water cycle. When we come to vegetation, the surface cover, what nature of plants that are covering that surface will affect the water cycle. There are plants that are ready with the stomatas up that will take in water very fast and ensure that this water is released through leaves back to atmosphere. And we have plants that are made in such a way to resist evaporation and transpiration. So the nature of vegetation we have, it will affect the water cycle. Some trees, some plants will release water back to atmosphere very fast, others will not. Others will shed their leaves and no water will be released to atmosphere at any speed. So we're saying the type of environment and the plant growing will affect the rate of transpiration Like for instance, we have the cacti plants. They transpire less, they survive in the desert, they conserve water. So there are some plants, they tend to stay and stick with water for a long period. They're adapted in a desert region, so the few amount of water they receive, these particular plants, they ensure they utilize and they keep it for a longer period. They just don't release water anyhow. But there are some plants, well, maybe they are located in equatorial forests, they are ready to release water very fast because the water maybe is available throughout the year. It's a rain forest area. It rains throughout the year, 12 months. So you'll find the nature of trees there will be losing water very fast to the atmosphere. Another factor that will affect the water cycle is the amount of sunshine. That's another factor. So, amount of sunshine. The energy needed to evaporate water comes from the sun. The energy needed to evaporate water, whether it's from leaves, whether it's from the surface of the oceans, that energy comes from the sun. Parts of the world that have a lot of sunshine have more evaporation, and part have more evaporation and transpiration when we're talking about the plants. But part of the world where it is cloudy and maybe areas where there is less sunshine, then that particular part, there is less evaporation and less transpiration. So we are saying the amount of sunshine is very important. It's another factor that we consider in water cycle. It will affect the rate at which water is leaving the ground, leaving the trees, going through the stem, through the leaves and back to atmosphere. So if it is cloudy, there's no sun, then we expect that evaporation will not take place. Evaporation will only take place when there's enough sunshine to cause it and so forth. So we have seen a number of factors that affect, the water cycle. We have also said even the state itself of water, when it rains, where does this amount of water go? Does it go and find itself trapped within the impervious rock? There's a pervious rock, and the impervious rock, is it trapped there? Then if this water is trapped there, it will stay there for millions of years before it finds its own way back, maybe through boreholes and wells, back to atmosphere. Or is this water trapped in the northern side, northern pole or southern pole? It is ice, glacier. Then if it's trapped that way, it will take a longer time for it to complete the water cycle. Now, we can have some revision questions just to test whether we have understood what water cycle is all about. Question number 1. Question number 1 is, state how much Earth's surface is covered by water. State how much Earth's surface is covered by water. This question requires you to recall. So if you have a good memory, good mind, you remember when we started this topic, we said 7% of the Earth's surface is covered by water. So it is 70%. 70% of Earth is water. That one only leaves us with the 30%. That is land. Then the second question we have is, state how much earth water is salt water, then B, fresh water. State how much earth is a fresh water. State how much earth water. For this question to make sense, how much earth water? Yes, how much earth water is a fresh water, then B, salt water. Now, this question also deals with simple understanding memory. Can you remember some of the facts? We drew a diagram showing the percentages, and we said that salt water that occupies most lakes that we have and oceans, it is 97.5%. So 97.5% is what we term as fresh salt water. And then fresh water, we said first 0.25% is fresh water, but trapped underground and in form of ice. But the fresh water that is available for use, we said it is 0.1%. 0.1%, if you go to our diagram, is fresh water available for use. Fresh water that is available for use and renewable water, 0.01%. But in total, if we talk of fresh water, then we have zero fresh water, we have 2.5% fresh water, but another water is trapped within the earth, and another one is in the form of frozen ice. Then, last question, and we shall stop on question number 3. List natural factors that influence water cycle. That is our question 3 last. List natural factors that influence water cycle. Those who can remember, this actually starting with the part where we were just winding our topic. We said some of the natural factors that influence the water cycle, just some. They said you list natural factors that maybe 3 or 4, but we have the landscape, the amount of sunshine, those who can remember, amount of sunshine, the landscape, air movement, those who can remember those factors, air movement, the state of water. It will affect the state of water, and the others. Those who can remember the temperature. The higher the temperature, the more evaporation and transpiration. That's all for today. Let us stop there. We shall have another topic next time.